In this class, we're going to consider how you simplify algebraic fractions. So first of all, what is an algebraic fraction? Well, if you've never seen these before, it's basically just what it sounds like. It's a fraction that contains algebraic terms. So, for example, this guy, in fact, all of these guys are algebraic fractions because they've got an algebraic term. You only need to have one x or letter variable term in there for it to be an algebraic fraction. But you can see they've got quite different formats, and we're going to chat about how we approach these different formats later on. But first of all, let's just think about what we might mean by simplifying an algebraic fraction. Well, the good thing about working with algebraic fractions is the rules are basically the same as numerical fractions. So if we think about taking a numerical fraction like let's say 9 over 15. So one of the things that we commonly do with numerical fractions is write them in their most simple form. So if we saw the fraction 9 over 15, we might think, well, is that in its lowest terms? If not, let's make an equivalent fraction which is in its lowest term. So both of these numbers, the numerator and the denominator, are divisible by 3. So we would probably say, right, we'll divide top and bottom by 3, and we get 3 over 5. So 3 over 5 is the equivalent algebraic fraction to, numerical fraction to 9 over 15. If we then just extend that idea to an algebraic fraction, so let's say we had 6a over 18a squared. So this is now an algebraic fraction, but we can still ask the question, is it in its lowest terms, or can we simplify it down? So we check the numbers and we check the algebraic terms. So in the numbers, there's a common factor of 6, so we can divide top and bottom by 6. So let's go ahead and do that. So dividing the 6 by 6, we get 1. Normally we wouldn't write in the 1, but I'm just writing it there for just for demonstration. And then on the denominator, we get 18 divided by 6, which is 3. And then if we look at the algebraic terms, it's always a little more awkward to think of dividing algebraic terms, but we can basically divide top and bottom by a. A is a common factor between a and a squared. If you divide the top by a, divide a by a, you just get 1. So we would end up kind of with 1 times 1 on the top. And then if you divide a squared by a, you just get a. So 1 times 1 obviously just becomes 1, so you'd end up with just 1 over 3a. So these guys might look different, but we've essentially done the same thing. We've taken the original fraction and written it in its lower terms in its equivalent form. Same with this guy. The only difference is here our common factor was numerical, and here the common factor was both numerical and algebraic. So when we take this kind of simple example and move it up to these more complex examples, we're essentially doing the same thing. We're looking for a divisor between the top and the bottom, the numerator and the denominator, that we can divide through to simplify. As we get to the more difficult ones though, we'll need to consider how are we going to go about that process. The process is going to get a little more challenging. So starting with this first one here, right, we could just look at these terms, so 12, 9, and the 6x term, and kind of just see that there's a common factor of 3. So we could go straight to just dividing everything by 3, and that would be fine. But that method of just looking at things and dividing, it might be good for a couple of these, but then it's going to start to break down over here where you can see there's no common factor between a number term, 3, and then all these algebraic terms, and the same down here. So we need a more formal method to go about it, and the formal method is factorising. So what we do with these, we basically look and see, is there anything that factorises? So on the top line, obviously not, you've just got a 12. On the bottom line though, there is a common factor of 3 between the two terms, so we pull out 3 as a common factor, and then just factorise using one bracket. So we get 3 bracket 3 minus 2x, so that's the bottom line factorised. What we now do is basically just look for a common factor between these two, which is 3, and then divide top and bottom by that common factor. So dividing 12 by 3 and we get 4. Dividing this 3 by 3 and we just get 1, so we would just be left with the bracket. Because that 3 is becoming a 1, we don't really need the bracket then anymore, so we would just write our final answer as 3 minus 2x, which is what we would have got anyway if we just divided everything by 3. But this is really the key step in here, the one that's got the factorising in it. Now for this example, like I've said, we don't need that step. That would kind of almost be overkill. Although it is good to show that as part of the process. But when we get to the more complicated examples, and these are more realistic for what you'll probably have to work with, it's better to get into the habit of factorising. These questions are always about factorising. Okay, so turning to the second one, again, you can see looking at the three terms, there's a common factor of x. We could just go ahead and divide through by x, and that would be fine. But let's go through the more formal method again. So looking at the top line, there's a common factor of x. So we pull that out and put it in front of a bracket, a term, leave the 2x on the bottom. And then we can just see that there's a common factor of x between these two. So we could divide top and bottom by x, or you could just think of it as cancelling the x's, I guess, which the divide effectively does. And we would just be left with a plus b over 2. So again, with that one being a fairly basic example, we could just go, right, let's cancel the x, x, and x by dividing top and bottom by x, and we would get straight to that point anyway. That's okay. It's just kind of good to remember that really you're getting there by factorising and then dividing. Okay, cool, right, so I think that gives us the idea for these, and then moving on to the slightly more complex ones. So we're just going to do the same thing though. We're going to factorise. It's just that we require different types of factorising in these. So the top line has got a common factor of x. So we're just going to use a common factor in one bracket, x plus 3. Just going to move this example out of the way because I think it's going to get in our way in a moment. So that's fine for the top line, and then for the bottom line, the denominator, we've got a trinomial. So we're going to need to factorise this one into two brackets. One of the keys with these questions, especially when you've got trinomials, and especially when it's the second thing you're factorising, we know that something's going to have to cancel here, because these questions are designed so that something does cancel. That tells us one of the brackets on the bottom is going to be the same as the bracket on the top. But just keep that in the back of your mind. Don't go straight to just writing that in. Think about the factorising first. So that trinomial would factorise with an x and an x. And we've got this expectation that one of the brackets will be x plus 3. The trinomial's got a 3 on the end, so that needs to be a 3 and a 1, because 3 is a prime number. The only factors are 3 and 1. And then it's a plus and a plus, so quite an easy one this actually. And we just put in the 3 plus 3 and the plus 1. And that gives us x squared, gives us a 3x and a 1x make the 4x in the middle. So we're just going to do the same thing that we did over here and down here, which is basically to divide top and bottom by some common factor. The common factor here though is the whole bracket x plus 3, which might seem a little confusing at first, or if that is confusing, just think of cancelling those brackets, because we can kind of cancel like that when we've got a fraction, if the bracket is multiplying to everything else that's on the bottom or the top line. If you've got a number here, if you have like a plus 5 on the end, then you cannot divide or cancel the x plus 3, because you would need to divide this by x plus 3 as well. But these questions will be designed so that that does not happen. So now we can just basically get rid of that x plus 3, and we end up with x over x plus 1. So that's a pretty typical case, to have this kind of binomial term on the top and then this trinomial on the bottom, or the other way around. Okay, right, so let me just fire up that example that I had a moment ago. If I can remember it, I think it was x squared minus 1 over x minus 1. I think it was that, let's go with that. So similar scenario, but just a different type of factorising required. So this doesn't obviously look factorisable, but this is the one that everyone forgets. This is a difference of 2 squares. So we just need to put that one into two brackets. So if you're not sure about how to factorise these, and maybe check out the class on this at some point, it's quite a simple technique. I'm not going to elaborate on how I got that, but basically that's how you factorise using a difference of 2 squares. The bottom line's not factorisable. It's already in its kind of lowest term, so we just leave that where it is. And now we can see we've got a common factor of x minus 1, top and bottom. So if we divide by that common factor, we would just end up with x plus 1. Yeah, that's basically how you simplify algebraic fractions. They're not terribly difficult. The absolute key is factorising. That first line of working should always be a factorising. As the expressions get more difficult, the factorising will get more difficult. But this is probably your worst case scenario, really. Would be a trinomial, or maybe even a trinomial and another trinomial. But a common scenario would be a trinomial and a binomial. So probably focus your attention on those. But it's good to try a variety of these because algebraic fractions are kind of everywhere. You're going to use them a whole bunch, I would imagine, in the future. So it's best to get really comfortable with them. The challenge that most students face with these is, one, remembering to factorise, and then two, being able to do the factorising. So if you're running into trouble with the factorising, maybe check out some classes and some practice questions on those first, and then have a go at these algebraic fractions. But in general, do some practice questions on these because they are a really common technique and a common topic.